Hello everyone. Welcome to my YouTube channel on engineering mathematics. In this video, I am going to discuss the concept of double integrals. I will also discuss the examples on double integrals with step-by-step solution. So let us first see definition and notation of double integrals. Double integrals are defined as follows. Integrals of a function of two variables over a region in R2 are called as double integrals. The double integral of a function f of x comma y is usually denoted by this notation, where R is the region of integration and dA is the differential area. It is usually dx dy or dy dx. Now let us see geometrical interpretation of double integrals. For that, first we recall the geometrical interpretation of single integrals. Recall that the definite integral of a function of one variable, say f of x, that is integral of f of x dx over the limit a to b, is the area under the curve f of x from x is equal to a to b. That is, if this curve represents y is equal to f of x and these are x is equal to a and x is equal to b lines, then integral of f of x dx over the limit a to b represents this area shaded in pink color. Similarly, double integral is the volume under the surface z is equal to f of x comma y and above the xy plane in the region of integration R. Look at this diagram. This is surface z is equal to f of x comma y and this cylindrical shape is your region of integration R. Then double integral of f of x comma y over dx dy or dy dx is nothing but volume under this surface over the xy plane. I hope you understood geometrical interpretation of double integrals. Now, let us see how to evaluate double integrals. To find the value of double integrals, we have to solve the double integrals from inside outwards as follows. This is double integral of f of x comma y dx dy. This we can write as integral of f of x comma y dx dy. I hope these parentheses must have cleared the idea of evaluation of double integrals. So first we have to evaluate this inside integral and then we will evaluate integral of value of this integral with respect to y. But for that, one should recognize the order of evaluation of these integrals. So now we see how to recognize the order of evaluation of these integrals. If the double integral is given in the form integral from a to b of integral from p of x to q of x of f of x comma y dy dx, then this dy dx is the order of integration. Actually, this integral is in the form this. Here you can clearly see that these inside integral limits are of y and outside integral limits are of x. So whenever we see inside integral limits are in terms of x, like p of x and q of x, then the order of evaluation of inside integral is dy and outside integral is dx. Similarly, if the double integral is given in this form, which is actually of this type, that means inside integral limits are in terms of y and outside integral limits are constant, then order of evaluation is dx first and then dy. I hope you understood what is the order of evaluation of double integrals. Now, let us see examples. In this first example, we are asked to evaluate this double integral of x square plus y square x dy dx over the inside integral limit 0 to x and outside integral limit 0 to 1. Let us first label this integral as I. Now, first we observe the inside integral limits. Since inside integral limits are in terms of x, the order of evaluation of inside integral is dy and outside integral is dx. So let us evaluate this inside integral. First, we simplify this integrand by taking this x inside. So we have x cube plus xy square as integrand. Then we put parenthesis just for the sake of simplicity. So let's evaluate this inside integral with respect to y first. Integral of x cube with respect to y will be x cube y, and integral of xy square with respect to y will be x y cube by 3 over the limit 0 to x. Now let's substitute these limits in y. So after substituting x in y, we have x cube into x, that is x raised to 4, plus x into x cube by 3, that is x raised to 4 by 3. Now we substitute lower limit in y, putting minus sign here. So we have 0 into x cube, that is 0. 0 into x is 0. Now let us evaluate this with respect to x. So integral of x raised to 4 is x raised to 5 by 5, and integral of x raised to 4 by 3 is x raised to 5 by 3 into 5, that is 15, over the limit 0 to 1. Now let us substitute these limits in x. So we have 1 by 5 plus 1 by 15 minus 0, 0. 1 by 5 plus 1 by 15 is 4 by 15. So 4 by 15 is the value of this double integral. I hope you understood every step of solution of this first example. Now let's go ahead for next such example. Here we are asked to evaluate double integral of e raised to x plus y dy dx over the inside integral limit 0 to x and outside integral limits 0 to 1. Once again, first of all, we label this integral as I, and then we observe the inside integral limits. Since inside integral limits are in terms of x, so we evaluate this inside integral with respect to y. This e raised to x plus y can be written as e raised to x into e raised to y. Since we are evaluating this inside integral with respect to y, so this e raised to x is constant. E raised to y's integration is e raised to y. Let us substitute these limits in y. When we substitute x in y, we have e raised to x minus e raised to 0 is 1. So this is the value of inside integral. Now we multiply this e raised to x inside to get e raised to 2x minus e raised to x. Now let us evaluate this integral. Integral of e raised to 2x is e raised to 2x by 2 minus integral of e raised to x is e raised to x over the limit 0 to 1. Now let us substitute these limits in x. So when we put 1 in x, we have e square upon 2 minus e raised to 1 minus, when we substitute 0 in x, we have e raised to 0, that is 1 by 2 minus e raised to the 0, that is 1. Now let's simplify this. 1 minus half is half. So we end up with value of I as e square by 2 minus e plus half. Now let's go ahead for next example. Here we are asked to evaluate double integral of e raised to y by x dy dx over the inside integral limit 0 to x square and outside integral limit 0 to 1. Let us first label this integral as I. And now observe the inside integral limits. These limits are in terms of x, that is, these are y limits. Therefore, we will evaluate this inside integral with respect to y first, and then we evaluate outside integral with respect to x. So let us evaluate this inside integral keeping x constant. So e raised to y by x integration is e raised to y by x upon 1 by x over the limit 0 to x square. This outside integral and this order will remain as it is. Now let us substitute these limits in y. So we have e raised to x square by x, that is e raised to x minus e raised to 0, that is 1, upon 1 by x as it is. This 1 upon 1 by x can be written as just x in the numerator. So when we multiply that x with this numerator, we have x e raised to x minus x. Now let us evaluate this integral with respect to x. To evaluate integral of first term, we have to use by parts rule, taking u as x and v as e raised to x. So integral of x into e raised to x is x into integral of e raised to x, that is e raised to x, minus integral of e raised to x into derivative of x, that is 1, turns out to be just e raised to x, minus integral of x is x square by 2 over the limit 0 to 1. Now let us substitute these limits in x. We then have 1 into e raised to 1 minus e raised to 1 minus 1 by 2, minus substituting this 0 in x, we have 0 minus e raised to 0, that is 1, minus 0. So after simplifying, we have e minus e, this gets cancelled, minus half minus minus plus e raised to 0 is 1. So we have minus half plus 1, that is just half. So value of this integral is half. Now I have a couple of practice example for you. I want you to try to solve these examples and write me in comment box whether you are able to solve them. I have mentioned the final answers of these questions. You can pause the video and note down these questions. Now let's go ahead for next example. Here we are asked to evaluate double integral of r dr d theta over the limit 0 to a sine theta and 0 to pi. First of all, we label this integral as I and observe the limits of inside integral. Since inside integral limits are in terms of theta, we evaluate this inside integral with respect to r and outside integral with respect to theta. So let us evaluate this inside integral with respect to r. Integral of r is r square by 2 over the limit 0 to a sine theta. Now let us substitute these limits in r. So after substitution, we will be having a square sine square theta upon 2 minus 0 by 2, that is 0. Now this a square by 2 is constant, we can take it out, and this sine square theta can be written as 1 minus cos 2 theta by 2. This 2 we can also take out, and outside we will have a square by 4. Integral of 1 is theta and integral of cos 2 theta is sine 2 theta by 2 over the limit 0 to pi. Now let us substitute these limits in theta. When we substitute pi in theta, we have pi minus sine 2 pi by 2 minus, after substituting 0 in theta, we have 0 minus sine 0, which is 0 again. Sine 2 pi is also 0. So we will be left with a square pi by 4 as value of this integral I. I hope you understood this solution. Let us go ahead for fifth example. Here we are asked to evaluate this double integral of r sine theta dr d theta over the inside integral limits 0 to a cos theta and outside integral limits 0 to pi by 2. As usual, first of all, we label this integral as I and observe the limits of inside integral. Inside integral limits are in terms of theta, so we have to evaluate this inside integral with respect to dr and outside integral with respect to d theta. So let us evaluate this inside integral. Since we are evaluating it with respect to r, we have to keep theta constant. So sine theta is constant. Integral of r is r square by 2 over the limit 0 to a cos theta. Now let us substitute these limits in r. So we have sine theta as it is. This becomes a square cos square theta upon 2 minus 0. I neglect to write that 0. Then this a square by 2 is constant. We can take it out. Now this cos square theta can be written as cos theta into cos theta. Then sin theta into cos theta can be written as sin 2 theta by 2. This cos theta as it is. Let us take out this 1 by 2 constant. So we have a square by 4 outside the integral, and inside we will have sin 2 theta into cos theta. This is like sin A into cos B. Sin A into cos B's formula is 1 by 2 sin A plus B plus sin A minus B. So here A is 2 theta, B is theta, A plus B will be 3 theta, A minus B will be theta. Let us take out this constant 1 by 2. So we have a square by 8 outside the integral, like this. Integral of sin 3 theta is minus cos 3 theta upon 3, and integral of sin theta is minus cos theta over the limit 0 to pi by 2. Now let us substitute these limits in theta. So after substituting pi by 2, we have minus cos 3 pi by 2 by 3 minus cos pi by 2 minus, after substituting lower limit 0 in theta, we have cos 0 by 3 minus cos 0. Since cos 3 pi by 2 is 0, similarly cos pi by 2 is 0, first term becomes 0. Cos 0 is 1, so we have minus of minus 1 by 3 minus 1 over here. Now this minus into minus becomes plus here and here. So we have 1 plus 1 by 3, that is 4 by 3 into a square by 8. Since 4 2s are 8, so this 4 gets cancelled. Here we will have 2 into 3, 6. So a square by 6 is the value of the given integral. Now let us see next and the last example. Here we are asked to evaluate double integral of r upon 1 plus r square whole square dr d theta over the inside integral limits 0 to under root cos 2 theta and outside limits 0 to pi by 4. Now as usual, we first label this integral as I and we observe the inside integral limits. These are given in terms of theta. So we evaluate inside integral with respect to r and outside integral with respect to theta. To evaluate this inside integral, we are going to use a substitution technique. We will put 1 plus r square is equal to t. Therefore, 2r dr is equal to dt. Therefore, r dr is dt by 2. So this inside integral will now look like integral of dt by 2 upon t square. This half we can take out. Integral of 1 by t square is minus 1 by t. Then rewriting t as 1 plus r square, we will have this. Now let us substitute these limits in r. When we substitute this upper limit under root cos 2 theta in r, we will have minus 1 by 1 plus cos 2 theta. And when we substitute 0 in r, we will have minus of minus 1, that is plus 1. So after rearrangement, we will have 1 minus 1 upon 1 plus cos 2 theta. This 1 plus cos 2 theta can be written as 2 cos square theta. Now let us cross multiply this 2 and take it out. So we have 2 minus 1 upon cos square theta, and 1 by 2 when taken out will become 1 by 2 into 1 by 2, that is 1 by 4. So this 2 minus 1 upon cos square theta can be written as 2 minus sec square theta. Now we will evaluate the integral. Integral of 2 is 2 theta and integral of sec square theta is tan theta over the limit 0 to pi by 4. Now let's substitute these limits in theta. So after putting pi by 4 in theta, we get 2 into pi by 4, that is pi by 2, minus tan pi by 4, which is 1. Minus, after substituting 0 in theta, we get 0 minus tan 0, that is 0. That I neglect to write. So after simplifying, we have answer as 1 by 8 pi minus 2. This is value of the given integral. I hope guys you understood every step of this solution. Now I have couple of examples for you. Their solutions are also given. Please try to solve these examples and write me in comment box whether you are able to solve these examples or not. I'll be coming with more such interesting videos. Till then, keep watching. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.